All right, welcome back, everyone. So earlier today, we heard from our AWS leaders on the history of custom silicon at AWS and how Graviton processors were initially conceived and then developed. With this session, we want to dive deeper into Graviton and some of the architectural differentiators between Graviton 2 and Graviton 3. We have with us Stephanie and Arthur. Do you want to introduce yourself?
Sure. Go ahead, Stephanie.
Yeah, hey, thanks for having us. My name's Stephanie Hsu. I'm the Global Head of Business Development for AWS Graviton.
And I'm Arthur Petit-Pierre. I'm a specialist SA looking after the Graviton instances and helping customers to adopt them.
Okay, why don't we start off with talking about how customers can access Graviton and how can they reap the benefits of the price performance benefits that Graviton offers.
Yeah, it was great to hear from our leaders earlier talk about how AWS came to develop its own custom silicon. And I love the fact that our leaders come from different backgrounds. So Dave, for example, comes from a software engineering background, while Nafa comes from the hardware side. Because building infrastructure at scale, improving the performance of EC2 instances really requires a unique blend of software and hardware components. And Graviton processors and the AWS compute services built on top of them truly exemplify this. As we heard earlier, Graviton processors are custom AWS silicon built with 64-bit ARM processor cores. And these are designed and optimized specifically for cloud workloads running on AWS. And one of the most remarkable things I would say about Graviton has been the pace of innovation that we've seen from the Annapurna teams, with just three generations of instances launched in just 4 years.
But that's a phenomenal speed, right? 3 generations, 4 years in silicon. I think earlier our leaders were talking about the complexity of silicon, about the design of silicon. We'll talk about that as well when we get to talk a little bit about designing silicon using the AWS cloud. But the complexity of designing silicon, the timeline that it takes, the ability in that environment to have had 3 generations since 2018, so 4 years, right?
Yep.
That's pretty significant.
Yeah, and since the launch of that first processor back in 2018, the goal has been to push the price performance envelope for a wide variety of workloads running on EC2. And with each subsequent generation that we've had, first Graviton 2 and most recently Graviton 3, we've been able to deliver step function improvements for customers in terms of price, performance, and workload supported.
And by step function, we were talking about what kind of performance improvements?
Up to, step function improvements. 25%.
25%. Right. That's tremendous.
20,
yeah. So we've seen a lot of fast innovation from the Annapurna team.
Okay, so we talked a little bit about Graviton to get started here. How many instances are there from Graviton? Like how big is our Graviton family?
Yeah, so today there are 13 different instance types powered by Graviton. So for general purpose, memory intensive, storage intensive, and accelerated compute workloads, we have the Graviton 2 enabled instances across the M, T, R, I, and G families. For compute and network intensive workloads, we have the C family that feature both Graviton 2 as well as our most recently launched instance C7G, which is powered by Graviton 3. So each of these instance types are going to offer up to 40% better price performance and are priced at up to 20% lower than the comparable x86-based instance.
Wow. Those are some pretty impressive performance numbers, especially when you compare that to where we are on x86. So what type of customers and workloads are being run on Graviton today? Can you give us an example of that, Stephanie?
Yeah, so as we talked about, the goal has been to be able to support a wide variety of workloads on EC2. So some good examples are CoreLogix. They transitioned their Elasticsearch nodes, which are processing 2 petabytes of ingested data per month, over to R6G instances. And they saw a 20% performance improvement, 40% lower load, and 22% price reduction over comparable x86 based instances. Another great example is Nextroll. They're running their web server and stream processing workloads on Graviton, and they reported a 50% savings over previous generation instance types. And the last one that I think is really cool to talk about is Epic Games, because they're using Graviton to power Fortnite and Unreal Engine, and they found that C7G instances meet their requirements for those demanding kind of latency-sensitive workloads.
I think everybody has probably heard of Fortnite, even if you aren't an active player. And those of us who have played Fortnite a million times, it's kind of impressive that you can see the complexity of that game, which is reflected in the need, right, for the performance. Anybody who has talked about latency and performance, it's huge there.
Yeah, that's definitely one of the ones that I loved. Those guys have been doing such an amazing job. So we sometimes have customers who are like, oh, but moving to Graviton, that's a new architecture. We have some highly tuned kind of software, and porting that might be hard. Those guys at Epic, when migrating the Unreal Engine, basically took them a couple of weeks to get that huge C++ code base optimized over the years, a couple million lines of C++. Took them a couple of weeks to recompile that and run that on Graviton successfully. Still required some optimization and tuning, but still, they were able to migrate that pretty quickly.
Moving millions of lines of code into a new architecture is impressive that you're able to do that in such a short period of time.
Yeah.
I think that speaks to what we've been able to do with Graviton, the performance improvements, and I bet they've also been able to save costs by making that transition as well, right?
Definitely, that was one of the main goals.
One of the huge drivers, right? So.
Yeah, there's another kind of important and impactful aspect of Graviton that I want to make sure we talk about, which is its energy efficiency. And this is going to enable our customers to lower the carbon footprint of their workloads that they're running on Graviton and make progress towards their sustainability goals. So Graviton processors deliver the best performance per watt in EC2, using up to 60% less energy for the same performance than comparable EC2 instances. So this is one of the areas where owning the entire hardware and software stack of Graviton makes a big difference. Our engineers are able to design the chips and systems with the functionality that's optimized for AWS and leave out the processes that we don't need. So as a company, that's running very large data centers around the world, anything that we can do to improve efficiency can positively impact our energy consumption at scale. One great example of this that I just want to share is with our Graviton 3 instances. AWS designed the chip, package, and motherboard to actually fit 3 processors per server instead of 2. And so this is allowing us to maximize the available power per server rack. So these kinds of efficiencies allow us to lower our overall energy and carbon footprint, which lowers our costs that we can then pass on to savings to our customers.
It's incredible, yeah. We had actually talked about this in the sustainability session today, how just doing something as simple as adopting Graviton can really make a huge impact in terms of just the efficiency and just lowering your carbon footprint. So this is just amazing, just the performance benefit, price performance benefit, lower cost, and energy efficiency of Graviton. How can customers run their workloads on EC2 and really just get started today?
Yeah, there's a few areas I want to touch on here. So customers can run their Linux-based workloads on Graviton through a variety of ways. All of the major commercial Linux distributions, including Amazon Linux 2, Ubuntu, SUSE, and Red Hat, are going to support Graviton out of the box, as are many open source community-supported Linux distributions. Containers is another area I want to talk about. They're an especially popular way to run workloads on Graviton because of the broad multi-architecture support across popular orchestrators and image registries that enable customers to really seamlessly run on either Graviton or x86.
And just the general portability of containers in general, just make it simple to migrate from one architecture to another.
Yeah, absolutely. And we have a lot of customers doing this. So DirecTV is one great example. They've migrated their Kubernetes clusters running over 700 microservices for DirecTV Stream over to Graviton. And they achieved 25% lower operating costs in that process. Similarly, Domo migrated their Kubernetes clusters. These were running tens of thousands of pods over to Graviton, and that led to 20% reduction in spend, and that came from a combination of cost savings, as well as the ability to scale down their overall footprint because of the performance gains that they saw. So Graviton is supported by most of the container ecosystem today, including Kubernetes, Docker, and our AWS managed offerings, ECS and EKS. And then similarly with the image registries, Docker Hub, JFrog, or ACR, for example.
Yeah, just speaking of managed offerings, Dave Brown this morning mentioned the Graviton Fast Start program, which is an evergreen program to make it easy for customers to adopt Graviton through managed services as well as Amazon EC2. Mm-hmm. So, whereas last year the Graviton Challenge, we challenged customers to adopt Graviton in as little as 4 days and get that 40% better price performance. With managed services, we're seeing customers adopt Graviton, get the 40% better price performance in as little as 4 hours. It's just incredible how fast you can migrate and adopt Graviton with managed services.
Yeah, I'm super excited about the Fast Start program because of the expansion to managed services. And because in addition to ECS and EKS, which I already mentioned, Graviton's also available through a number of AWS managed services that we touch upon in the Fast Start program. So this includes Aurora, RDS, Elasticache, OpenSearch, and EMR. And these are really probably they are the easiest way to achieve the significant price performance benefits of Graviton with really little to no code changes. So, one good example here is Ascend Money, which is a fintech based in Southeast Asia. They migrated most of their EMR to Graviton in less than a week and saw 40% better price performance with 20% lower costs without any major code changes.
And what are we doing in the partner ecosystem or with our partners to just make them ready for Graviton?
Yeah, the software ecosystem is another important aspect. So I want to highlight the Graviton Ready program, which features partner software solutions that support Graviton, including operating systems, platform services, security, monitoring, data and analytics. So these are partners that are running quality assurance on their software and providing support for their solutions on AWS Graviton to help ensure that customers can have a consistent experience, whether they're running on Graviton or another instance.
Wow. So maybe we should switch gears a little bit and talk a little bit more about the architecture of Graviton itself, right? I don't think we shy away from how we have defined this ourselves. So Arthur, maybe we can talk about what makes Graviton different from other x86 based instances.
So, well, one of the first things is it's not x86, and as much as we would have loved to reduce the friction to adopt it. Well, that wasn't really an option to make an x86 chips. There's no license available to do that. So we decided to rely on the ARM64 architecture. And there are many reasons behind that. There's a solid ecosystem to help us to design those chips. And maybe more importantly than that, there's a super solid software ecosystem. The architecture has been around since a while, so there's support at the Linux level, there's support from a vast majority of open source software. So it was a really solid base on which we could build support for the Graviton chips and make the transitions for customers easier when moving to Graviton processors.
And there are a lot of developers already very, very familiar with that ARM ecosystem,
Sure.
right? I mean, ARM is powering a lot of things that everybody is using already. Just it's not some novel concept, right, in the cloud here.
Yeah,
I think it's just an addition to, and it's just new, a little bit newer to the cloud is where we are. So let's talk about some of the design decisions that we made with Graviton 2 and Graviton 3 to improve the performance.
Sure. So we sometimes claim that processor was designed for the cloud, and people are wondering what it means. So among the things that it means, there is the fact that we have chosen to have small, super efficient cores on it that are not implementing hyper-threading. So it gives us those really capable small cores that are super power efficient. And we expose them with one physical core per vCPU, contrary to what we do with the x86 architecture, where we have vCPUs mapped to hyperthreads. And the choice that we've done with Graviton is really good when it comes to performance at scale. With hyperthreads, when you're using two hyperthreads on a single physical core, you're getting the maximum performance at around 1.6, 1.8 times the single hyperthread. Whereas on Graviton, it just scales linearly, and when you're using two vCPUs, you're just getting twice the performance. And one of the consequences of that is our customers tend to be able to run their workloads hotter they can drive more performance from those smaller cores.
And that means you're more able to better and more efficiently use the CPU,
Sure,
right?
definitely.
So running hotter means you take advantage of all of that performance that we can offer, and
Yeah.
customers are able to do that a little bit better. So maybe talk about the memory topology.
Yeah, another thing that we tried to make simpler for customers is the memory topology. On most of our other instances, we have a memory topology which is not flat. We are exposing non-uniform memory access, and it has some complexity for people like databases, developers, those kind of workloads where you really have to pay attention to what you're doing with the memory. On Graviton, we have a flat memory topology, which means that wherever you allocate the memory, you get the same consistent latency and bandwidth from whatever core or from whatever core-to-core communication you're doing. And that makes the life of an application developer way easier. They don't have to pay attention to that anymore.
I think that this is kind of how we've designed this architecture, specifically for cloud, is also driving so many improvements in performance for customers as we do that here. So I think one other thing that we want to hit on is we're in, I think Stephanie mentioned this earlier, we're in full control over this entire design ecosystem. So maybe you guys can talk to us a little bit about how that benefits customers and has benefited the architecture.
Yeah, there's a couple interesting things that you can do when you control the full thing. There's, for example, the fact that with Graviton 2, we introduced our first instances with fully encrypted memory. So since we are designing the chips and we are designing the memory controllers, we were able to design the memory controllers in a way where we could encrypt the memory and decrypt the memory on the fly so that the memory would be encrypted all the time. And that's done without any impact on the performance.
Yeah, I think we talked a little bit earlier to JD Bean when he was here about this encryption, on the importance of the encryption on the fly for customers, and protecting data, I think, is the key thing here. So, and as you mentioned, that started with Graviton 2,
Yep.
correct? Okay.
And
so
we keep on doing that with Graviton 3, and there's no reason to stop, just to improve it.
So we have 2 generations that's out right now with the memory encryption as well. So we've introduced 3 generations in 4 years, right? And that has brought how much additional performance with each generation?
So if I remember well, Graviton 2 was roughly almost twice faster than the first generation, but that's a little bit of an odd thing. Between Graviton 2 and Graviton 3, we are roughly 25% faster for general purpose workloads, and significantly more for some of the more specialized workloads like AI and ML or vectorized floating point throughput, those kind of things.
Can you talk a little bit about the difference in architecture between Graviton 3 and Graviton 2 that really gives us that 25% better performance? Is it a big, beefier chip? Is it something else?
So the number of cores, the memory topology, those kind of things stays mostly the same. But the cores have been significantly tuned. We are using a new manufacturing technology, and that's part of what is giving us that 25% general purpose kind of performance. And then there are some more specific additions that have been made. So for example, we've doubled the number of 64-bit integer multiplication units, which is kind of doubling the performance for some cryptographic operations. Mm-hmm. We've doubled either the number of vector units or their size, depending on which instruction set we are using for vector operations. So with SVE, which is the latest generation of vector instructions on ARM, we now have the ability to manipulate 256-bit vectors, whereas we had 128 with Neon. And that is just doubling the vectorized floating point performance throughput. which has an influence on two kinds of workloads. One is anything that would be doing massive math-related simulation like HPC workload, but it also has a really positive influence on AI and ML workloads. And so for AI and ML, there's two things. There's that vector instructions and wider vectors, and there's the fact that we've introduced two new data formats, bfloat16 and int8, that are allowing you to represent floating point numbers and integers with a more compact representation. And the consequence of that is that you can build models that are more compact in memory. So you're using less memory bandwidth when executing those models. And the consequence of those two things is that you, in some cases, are able to run those models 3 times faster than you could in the past with Graviton 2. And there's one last thing. Graviton 3 is also the first server that we introduced with DDR5, which gives 50% more memory bandwidth. So again, that has a very, very positive influence on the performance.
So it sounds like what we've done here is with Graviton 3, we haven't just delivered on just performance, we've also delivered on first technologies as well in the cloud, right? The DDR5. And all of this helps improve performance together for customers and makes them more cost efficient. Combine that with our discussion earlier about the efficiencies on the sustainability side as well. Graviton 3 has made some really significantly powerful updates here for our customers.
Sure. So we launched 3 generations of Graviton in 4 short years, which is no small feat. We talk about getting customer input to help us make the decisions on how we innovate. Can you give us an example of how customer feedback is used to fuel innovation for features and capabilities within Graviton and C7G instances?
Yeah, there's for example, that thing where customers are very clearly concerned about security and they want to improve their security posture. With Graviton 3, we are introducing a new feature to reinforce that security posture that's called pointer authentication. That's basically the ability to sign pointers so that whenever an attacker would execute something that would change the pointers in memory, the processor could check at runtime whether the signature is still valid and raise an exception if that's not the case and crash the program instead of executing whatever attack, malware that the attacker would be willing to execute. Wow. So that's the kind of things that is helping at the hardware level protect a software system.
Wow. I think that's pretty impressive. So I think we talked a little bit about the pointer authentication as well. Here, maybe we can move to talking a little bit about some of the software that we have and the next releases that we have with software.
So Amazon Linux 2022, that is still in preview right now, will have some support for pointer authentication. So by default, with the latest generation of our software and the latest generation of Graviton processor, customers will have a more secured posture.
Yeah, so maybe we could also talk a little bit about how customers have, or give an example perhaps of a customer that's taken advantage of some of the memory bandwidth that we have, that we now offer, on Graviton 3.
Want to talk about it, or do you want me to talk about it?
I can do it.
That's fine. A good example, I was mentioning HPC simulation when talking about using more memory bandwidth. Formula One is one of our customers that is doing heavy HPC-like kind of simulation. So they're doing CFD to analyze the airflow on Formula Ones. And with Graviton 3, thanks to the DDR5, we are offering 50% more memory bandwidth. And that's usually the bottleneck for those applications. So for these customers, it is tremendously helping with how fast and how cost-effective they can run their software.
Wow. So there's a lot of innovation here with Graviton that we've covered in a relatively short period of time. Any last takeaways, Stephanie, that people should hear about and make sure they know?
Yeah, well, I talked earlier about the pace of innovation from the Annapurna team, and we've been talking about the Graviton processor here today, but really the innovation extends well beyond that. I mean, AWS has end-to-end ownership of the entire EC2 instance stacks. I know we've talked today about the Nitro virtualization platform, but this is really key to the strategy and where our kind of silicon journey began. So this is what allows AWS to really improve the performance, not only at the processor level, but also at the network and the storage level. The other thing with Graviton is you have full control of the hardware and software stack. So you're in a better position to handle issues, bugs, security concerns. So when things like hardware-related security issues is disclosed, for example, sometimes we have to wait a while for other processor vendors to sort of react and provide solutions. With Graviton, we have full control. So firmware, hardware, microcodes, any security issue that is disclosed, we can react very quickly. And so this is just a great example of the benefit of kind of owning the entire stack.
Yeah, and I think that benefit, it sounds like, was also manifested for customers, especially, right?
Right. It's all about customers.
Exactly.
Yeah.
Yeah, so in closing, thank you for coming today. Any resources that you'd want customers looking at to get started today with Graviton-based instances?
Yeah, we mentioned the Fast Start program earlier, which we're super excited about and highly encourage everyone to go check out. We also have a Graviton kind of getting started guide that's very technically in-depth kind of guidance on identifying optimal workloads, key considerations, how to test and benchmark your workloads on Graviton. We also have a free trial available through the end of the year, so you can actually get started at no cost with our T4G instances. You can get up to 750 hours per month through the end of the year. So even better, it's free.
Yeah, nothing like that word, right?
Yep.
People can get started easily.
You just got to get started, just got to try.
Yeah. So I want to thank both of you for coming out today so we could talk a little bit about Graviton. I think just the next thing that is going to come up here is I think there's nothing better than how to frame this is directly hearing from a customer. And so next up, we're going to hear a little bit from Liz Fong-Jones, who's a developer advocate at Honeycomb.io. I also encourage folks to take a look at Liz's Twitter feed as well, where she's pretty heavily a supporter of Graviton, as is Honeycomb. And you can even get more of kind of some of her personal experiences. But I just want to thank Liz for joining us. And just a note, we happened to bump into Liz at our AWS New York Summit. So, we did the recording outdoors in New York. So there's a little bit of audio there, but I think that it's still a really powerful
She's amazing
testimonial.
nonetheless.
Exactly.
Yes.
So, yeah, thank you very much.